Right, welcome to tutorial on operating systems. Topic is scheduling. Right. In this presentation, we'll learn about just the concepts. We'll do the algorithms in a follow-up, but today we'll just focus on the main concepts. So what you should pick up today: what does it mean if something is preemptive? What does it mean if it's non-preemptive? Non-preemptive, you will see in some texts they say cooperative. That means it cooperates, doesn't need to be stopped, forced to stop. And we also discuss various ways to characterize schedules. There's CPU utilization, throughput, turnaround time, waiting time. When we get to real-time systems, we will add a few more terms to this, such as latency and so on. Okay. Right. So previously in OS, we learned a process goes through many states, from new to ready, runs for a while. If it makes an I/O request, it will go to waiting state, and when the data or device or whatever it's waiting for in I/O is ready, it goes to ready. If there's any interrupt, the process will be stopped, sent to ready, and when the process finally completes, it goes to the terminated state. Right. In this case, there are two major things we want to pick up. That is, what does it mean if something is CPU bound? CPU bound meaning it's doing activity on the CPU, and I/O bound means that the process will be making requests for I/O. Maybe wants to read a device, wants to write some files, play some audio, anything I/O. Right. There are some cases where someone will just say, oh, this process is I/O bound. It means that the process would likely spend a lot of its work in I/O. And if someone says, oh, this process is CPU bound, it means it's going to spend most of its time in CPU. But in reality, most processes spend some time on the CPU doing active work and some time on the I/O. On CPU, central processing unit can be used for doing arithmetic operations, reading and writing to memory, which will not be an I/O block. I mean, if you just are writing to your own memory space, that will not block you. But if you try to write to a file, that will cause an I/O event. Right. So if we look at what's happening on the CPU, realize there are two types of changes of state, two ways to categorize them. In one group, where we say non-preemptive, means that something happening within the process is causing it to stop. That the process itself did something to stop. For example, it asked for something in I/O, it would stop. Or maybe it called the function sleep or pause to cause itself to stop. Right. But there are other times when the process has no control over what's happening. So, for example, the scheduler. So I'd say preemptive, usually from an external activity. The scheduler may, through some event, maybe knowing that you've spent too much time on the CPU, may cause you to stop. Or maybe there's an interrupt that happened. Interrupt meaning maybe an I/O event from somebody else or from hardware, something causing you to stop. So anytime it's coming from outside the process, we say it's preemptive, and if it's from within the process, we say it is cooperative. Right. So if we list out the things happening as far as activities, we can see the process can go from running to waiting due to an I/O event. That's considered to be non-preemptive because the process itself maybe try to read a file and so knows it's going to happen. Right. And if a process decides to stop for any reason, maybe to exit, so exit command. I would also add some processes may decide to sleep. I mean, it's not in the text, but if you decide to sleep, that is non-preemptive, right? But the preemptive, from running to ready, maybe due to an interrupt or a scheduler stopping you, that is preemptive. The process did not agree to stop, so it was preempted. And if a process is taken from waiting to ready, that is also preemptive. The process really doesn't have any say in being moved from waiting to ready. The process is not even running, actually. It's the scheduler. So there are a few ways to categorize the movements, and we talk about preemptive and non-preemptive. Alright, so going further. Right, so if we say a schedule is non-preemptive, or someone says non-preemptive scheduling, that means that the processes themselves decide to give up and let someone else have a go at the CPU. Maybe they sleep or they wait. In Linux, you may hear of commands such as nice. It's a command in Linux telling processes to be willing to give up the CPU more to allow others to run. Right. In Windows, you may be able to set the priority of processes to low, medium, high. Right. But that means usually that it's being preempted. That means the scheduler is enforcing these. Right. Okay. So a preemptive schedule is one where an external, maybe a scheduler, is causing processes to stop or run. Right. It's not a bad thing really. It's just to make sure everyone has a fair go at the CPU. Right. This is an example of a task manager, and it's showing CPU. That's how much time processors are spending on the CPU, and you can see things are changing around. There are different things that are running. Right. Python, Excel, Adobe, command prompt. There are a lot of things are running. So different people are getting to run the CPU at different points in time. Right. And I believe it should also be possible to see the I/O requests that processes are making. Alright, so let's continue. So you should know if someone says something is preemptive or non-preemptive as a schedule. Alright, the other things we're going to discuss was how we characterize schedules. So usually we talk about CPU utilization, and I believe you saw CPU, how it's being used. So someone is using some part. We can talk about CPU utilization for a specific program, or we can maybe look at the entire system and consider CPU utilization. So have a few cores, and each core has a certain way in which they are using the CPU. So that is 0 to 100% is that CPU utilization, right? You have turnaround time, which is the time from when a process is ready to start or has arrived. I shouldn't say ready, but when a process has been requested. So maybe you clicked start menu, or you typed something in the command prompt. That is really from that time when you entered it to when you actually finish doing all your work. That is a turnaround time. Right. So that means doing all your work, that means you're going to spend some time in the ready queue, some time executing, some time doing I/O. If we combine all that time together, so the moment we know, okay, something is new, it's ready to go, we start the timer, and you may go to ready. We are still counting turnaround. We add up how much time you're running, how much time you're waiting, went back to ready, swapped between running and ready a few times. All of that is considered to be turnaround time until you finish. When you finish, then that's some of the time you spent from here to there. That is your turnaround time, right? Waiting time is how much time you are waiting. So if you look at the diagram, except for running, you're actually waiting here when you do an IO event and when you're ready. Some people think ready means you are actually running, but ready doesn't mean you're running. Ready, you're actually not running yet. Running means you actually have use of the CPU. So anything outside of running, we consider that you're waiting, right? Okay. You also have response time, and this is important for usually interactive systems. I mean, someone has maybe pressed a button, right-clicked. How much time does it take between the time when the person asked for the activity and the time when he actually sees something on screen? Right. So there are many programs that will take some time. Maybe you are printing something. The response time is from the time when you clicked to print to when the first page starts to print. Right. Response time isn't until when you finish. It's just that small time between when you ask for something and when you get a response. You can think of it as maybe if you go to a restaurant and you entered and you asked for food, how much time does it take between when you ask for the food and when it actually arrives in front of you so you can start eating. That is the response time. Or maybe you called your friend, you would measure the time when you dialed till the time when the person picked up the phone. That would be your response time. So response time is just when you hear back. It doesn't mean when you finished. Turnaround would be from the time when maybe you called your friend till the time when you spoke to the friend and then they hung up. So that's the entire time. The example we are going to use is a car wash. Right? So we are using this case where we have a car wash with 3 workers, and what they do is they have only one place for washing the car. But of course, clients can line up their different cars. Right? When clients come, the workers may pick up a car, but if you pick up a car and someone else is in there washing the car, you can't put 2 cars in there. It's just for 1 car. So probably you have to wait, even though the client has come here ready to wash the car. So we are going to use this simple example to explain the different parts of scheduling. Right. So first we'd ask, what does it mean for, in this case, something to be non-preemptive? Non-preemptive would mean the moment someone goes in there, starts washing the car, nobody stops the person or interrupts. The person is allowed to wash the car, decide when they want to stop, take a break. They can keep the car in there as long as they want. Right? So in that case, maybe they can decide maybe they're going to buy supplies, they needed soap. That's non-preemptive. They made that decision. Alright, maybe they are getting lunch, taking a break. That means they decided by themselves, the worker, to give up the washing area. So that's what would be a non-preemptive schedule. A preemptive schedule would be one where maybe there's a manager or there's a timer telling them, oh, you've been there for too long, you have to stop. Something from outside the worker telling him or her to stop working or to take a break. So a preemptive schedule is one where people can be stopped, maybe asked to move the car out. And the non-preemptive is where they can use it for as long as they are in there. Right. So let's put in some numbers and see how you can do some simple analysis. Just the main ideas. We'll look at specific algorithms later. Right. So there are 4 workers. There's an arrival time. Abner in at 10. Kofi came in at 10:05. That's when he got a job. A job meaning a car came for him to wash. Alice at 10:10 and Sam at 10:11. They have I wrote CPU time just so you start getting comfortable. But basically, this is how much time they are spending in the washing area with the car. So Abner would like to spend 10 minutes. Kofi would like to spend 5 minutes. Alice, when she comes in at 10, wants to spend 10 minutes as well. And Sam wants to spend 2 minutes. Priority, I usually would say that maybe greater number is higher priority. So you need to ask if you're not sure what the numbers mean. There are some systems where 0 may be the highest priority, or there are some where there would be maybe 100 is the higher priority. So you have to ask, figure out. Okay. Alright, so using this schedule, we are going to do just a little bit of analysis, trying to understand and apply some of the things we learned. So if Abina got a job at 10 and nobody was interrupting her, that's, if you say it's non-preemptive, that means she's working from 10 to 10:10. No interruptions, right? 10 minutes. In the meantime, let's take Kofi. Kofi came in at 10:05, but if it was, and in this case we are talking about non-preemptive. If it was non-preemptive and Kofi was not allowed to interrupt in any way, Abna would be the only person working, and she would work for that amount of time. Right? So Kofi would have to wait while Abna was working. Alright, so that's 10 minutes for Abna, non-preemptive. Right, so that means Kofi would start his work from 10:10 up up until maybe 10:15. Realize there were two choices here. At 10:10, Alice was ready, Kofi was ready. But let's just say Kofi gets a 10. So Kofi gets to go from 10:10 to 10:15. That means that Kofi has been waiting for 5 minutes. At the same time, we would say that Kofi's response time is also 5 minutes, because it was 5 minutes before we actually started to see him do something, right? If Kofi worked from 10:10 to 10:15, his turnaround time is 10 minutes, because he was in at 10:05, but only managed to finish at 10:15. So his turnaround, so at the end of the day, you'd ask, how much time did it take from when you were ready to when you've actually finished? So turnaround would be, in this case, 15 minutes. So I think we've got most of the issues. So we talked about turnaround time, we talked about waiting time, response time. The next is utilization. As far as utilization for this, we are using the place 100% of the time. Right, so utilization is 100%. But what if, for example, Kofi came in at, Abna was the first person to come in at 10. She didn't really start working at 10, but decided, I'm on around, so I'm going to start at 10:02. That means she's going to work till 10:12, right? So for just that period of time, utilization usually, someone could ask you to do it for the whole schedule or for just the process, right? So if you look at just the time when Abna came in till 12:02, the utilization there is actually just 10 out of 12. Oh, sorry. Seems to want to do the computation. Okay, that is 83%, right? So you just have to figure out for how much time the CPU or whatever resource they are using is in use, and that would be your utilization, right? So let's talk about preemptive. Right? Preemptive means that for some reason, maybe someone could preempt someone else. Right? There were priorities before. Let me show the priorities. What if I swap the priorities around? Maybe give Kofi a priority of 20, right? That means Abna started working at 10, right? And she wanted to finish at 10:10. But if Kofi had higher priority, and we said we're going to allow preemption based on priority, then Abna will be stopped at 10:05. And then Kofi, having the highest priority, would do his work. He's running for 5 minutes. He'll go from 10:05 to 10:10. Right. At 10:10, even though Alice is in, Kofi has finished, but Abna did not. She's currently the person with the highest priority. She can get to go from 10:10 till 10:15. Right. So just looking at what Abna goes through now. Right. Abna's wait time is 0. She didn't have to wait. From the time when she came in, she immediately got to work. So looking at the characteristics, wait time, her response time would be 0, but her wait time, if you look at it carefully, not 0. Abna's wait time is actually, she has some time here that she was forced off. She has about 5 minutes of waiting. So for wait time, make sure that you capture both the time before the process started and the time when they are kicked off for any reason, right? In this case, Kofi's waiting time is 0. He didn't have to wait, he didn't have to pause, but Abner's waiting time is 5. Now Abner's turnaround time in this case is 15 minutes. Turnaround meaning when she started to when she ended, that's 15 minutes. Her response time is 0. The moment she got the job, she started working. And same for Kofi. The moment he's got the job, he started working. But in that case, you can tell that someone like Alice and Sam, they are having to wait even longer. So response time for them is an even longer period of time. Right? So depending on the type of schedule you are doing, if someone says it's preemptive, then you have to ask, what is the preemption based on? Sometimes they would say it's based on priority, maybe it's based on time. There are many ways a scheduler could decide to do preemption. So you have to ask, what type of scheduler is it? How is it doing preemption? Is it even doing preemption? The most common ones in the textbook tend to be based on non-preemptive schedules. And non-preemptive just means when someone starts running, nobody stops it until it finishes. Right? So I'm hoping that with this example, you've seen the concepts, right? That is CPU utilization, throughput, turnaround time, waiting time. We've also spent a lot of time talking about preemptive and non-preemptive. Along the way, we talked about CPU bound and IO bound. If you hear the term, you should know what that means. All right, so that's the end of this. We'll continue in another video, the different types of schedules you can have. Thank you.